Hello everyone, I am Someshri Senapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So in our previous classes, we have continued solving numericals on cantilever beam, and here in this class we will solve different types of two numericals on basis of cantilever beam with application of UDL. So let's solve, and here you can see we have the AB cantilever beam, and at point A the beam is fixed, and here at point B we have the end support and there is no fixed beam. So you can see the applied load is BC, UDL is applied here with 60 kilonewton per meter load, and the beam span we have taken is 2.5 meter. So now our work is to find out what? Shear force and bending moment. So calculation of shear force. Okay. So first we will solve from point B. So shear force at B will be what? Here you can see at point B there is no load. So we will have force as 0. Next, shear force at point C. So shear force at point C will be your 60 kilonewton multiplied with 1.8 meter. So 60 will be multiplied with 1.8. So let's have the calculator. Multiply with 1.8. So we will have 108. 108 kilo Newton. Okay. And shear force at point A. So you can see this gap. Here to here we don't have any other forces. So at point A we will have the same force, that is 108 kilo Newton. And again here we have the shear forces. Let's go for calculation of bending moment. So first thing, bending moment at point B. Okay, bending moment calculation is nothing but your force will be multiplied with distance. So here we don't have any forces. You can see from this, right? So 0 will be multiplied with 0 and we will have 0 kilonewton into meter. Next, bending moment at point C. So how to calculate? Here at point C we will have 60 kilonewton with multiply with 1.8 meter. You can see the same answer. Shear force and bending moment will be same at this point, that is 108 kilonewton into meter. Okay, but this 108 kilometer will be multiplied with this much distance. So 1.8 will be divide 1.8 by 1.8 by 2. We will have 0.9. So 0.9 with multiply with 108 kilonewton, 97.2. 7.2 kilonewton into meter. You can ask why we multiply this much. Okay, here the whole force will be what? 60 multiplied with 1.8 and it will apply at the center. Okay, so we need to multiply this distance. Okay, so here the formula will be 60 into 1.8 into 1.8 by 2. Okay, again bending moment at point what? Bending moment at point A. Similarly, this 60 into 1.8 will be multiplied with, here we will have the negative values. So, 60 into 1.8 will be multiplied with what? We need to divide this 0.9 plus this distance. What will be this distance? It will be 2.5 minus 1.8. It will be 0.7 meter. So what we will multiply? We will multiply 0.9 plus 0.7. Okay. So 0.7 plus 0.9, 1.6, and 1.6 will be multiplied with 108. We have 172.8 kilonewton into meter in negative values. Okay, as we have already discussed, as this load in downward direction, so we will have negative bending moment values. Now our work is to do the shear force and bending moment diagram. So we will have three values at A, C and B. We have already calculated, and let's put those values here. So you can see we have the shear force values in positive. So here at point B we have what? 0. So here we will have 0. Here we will have 108 kilonewton at point C. And similarly at point A we will have the same value, that is 108 kilonewton. So here this part will be your shear force diagram. Positive shear force. Okay. We have SFD, ACB. Okay. Next, let's draw the bending moment diagram. First, we will start from 0. Here at point B, we will have 0 kilonewton into meter. Again, at point C, minus 97.2. Make it here, minus 97.2 kilonewton into meter. And last, minus 172 kilonewton into meter. Okay. Now our work time is to remember that in case of BMD, while application of UDL, in case of cantilever beam, we need to draw a what? Parabolic structure. Okay. It will be look like this. And here at point AC, you can see there is no forces. So we will have the linear diagram. Okay. It will be negative. Now here we have ACB BMD, that is your bending moment diagram. Okay, we just need to remember in case of UDL and cantilever beam we will draw parabolic structure, right? So okay, here this is the simplest question, and now we have another one question, but okay, here you have the question like this, and we need to draw the question and then we'll solve the answer. In your examinations, generally there is no questions. Okay, you just need to first draw the question perfectly, then we'll solve. As first thing given is a cantilever beam of 3 meter long. Let's start drawing with cantilever beam. Okay. That 3 meter long is loaded with what? UDL at distance of 0.5 meter. So from 0.5 meter we will have one UDL. The fixed end and a point load of 60 kilonewton is at the end of UDL at the distance of 0.5 meter. Like that say from this end we will have one point load. Let it be here. The point load is of 60 kilonewton. Okay, it will be 0.5 meter distance from last end. And here UDL will start up to this. So this distance is also 0.5 meter. Okay. So here to point load will be application of UDL. UDL is of 3 meter long loaded with UDL 0.5 and the fixed end. UDL given here, let it be 60 kilonewton into meter. And the whole distance is 3 meter. So you can know from this that this is 0.5 and here we have 0.5. The total is 1 meter and the total here is 3 meter. So this to this distance will be 2 meter. Okay, the UDL is applied at 2 meter of distance. So now we have drawn the question. Let's start solving. So first thing we need to do, let's name it here A, the input is B, C and D. So let's start from point B. Calculation of shear force. Right. So first thing at point B, shear force at B will be 0 because there is no forces. 0 kilonewton. Again, shear force at point C. What? The point load is there. So we will have positive 60 kilonewton of load. 1, 2 and 3. Shear force at point D. It will be 60 plus the 60 kilonewton into meter, kilonewton per meter. Okay. Will be applied at 2 meter of distance. So it will be 60 plus 60 into 2. It will be 60 plus 120, that is 180 kilonewton. Right? Again at point A. Shear force at point A. What we will have? The same, because from D to A there is no forces. So 180 kilonewton. Now we have the shear force values. Again, let's calculate bending moment. Okay. So calculation of bending moment will be start from here. Bending moment at point B will be 0. Why? There is no force. We need to multiply force with distance, but there is no forces. So at point B we will have 0. Again, bending moment at point C. At C will be what? Here we have the point load, but you can see there is no distance from this side. So also a bending moment, let's say we will take 0 kilonewton into meter. Bending moment at D. Now our work will be started. Like first point load, let's take minus 60 will be multiplied. This point load will be multiplied with this distance. 60 will be multiplied with 2. Again minus 60 into 2 will be multiplied with what? 2 by 2. This will be 1. So minus 120 minus 120. Minus 120 minus 120, it will be minus 240. Minus 240 kilonewton into meter. Okay. Bending moment at point A. Now, what we will multiply? Like this 2 meter, 60 kilonewton will be multiplied with 2 meter plus 0.5 meter. So, minus 60 into 2 plus 0.5, that is 2.5. Okay. And minus 60 into 2 will be multiplied with 2 by 2 plus 0.5. So, here it will be minus of 60 into 2.5 and minus of 120 into 1 plus 0.5, that is 1.5. So, 60 will be multiplied with 2.5, that is 150 plus 120 into 1.5. Here we will have minus 330. Minus 330 kilonewton into meter. Okay. We have the shear force and bending moment values. So let's start the drawing. First thing, we need to took spaces for SFD and BMD, and from different points we need to find out shear force and bending moment values. Okay. So first we will draw SFD. SFD will be at point B. Here we will have 0 kilonewton. Again at C 60 kilonewton. At D we will have 180 kilonewton, and at point A similarly 180 kilonewton. Okay. In case of shear force diagram, all the points will be linear. There will be no parabolic structure. Okay. C. And we have positive SFD. Okay. Next part is BMD. So you can see at point B we will have what? 0. 0 kilonewton into meter. Point B, C here we will have 0 kilonewton into meter. Bending moment at D will be minus 240. And here minus 330 kilonewton into meter. Okay, so we will not join this, but here we will have the parabolic structure. Okay, and here you can see there is no forces, so have the linear. This part is your bending moment diagram, and we have the negative bending moment diagram here. Okay, if you have any doubt, just take a screenshot and we'll solve it properly again and use calculator for the appropriate answers. So here in this class we have discussed two numericals, and in our another classes we will solve more numbers of numericals on basis of cantilever beam, and will apply UVL and other things. So you need to stay tuned. Thank you so much.